Okay, lesson 6.6. We are looking at function operations. We're looking at dealing with functions like f of x, g of x, those type of things. And on this front page today, just some basics. How do we add functions? How do we subtract functions? How do we multiply functions? How do we divide functions? Depending on the function, it can be very easy or it can be a bit more challenging. So, if you look up at the top there, it just goes through some basics. F plus g of x. So that's saying, okay, if you're asked to add f plus g of x, that's just saying that you add f of x plus g of x. If you're asked for f minus g of x, that's just saying you do f of x minus g of x. If you're asked for fg of x, where f and g are multiplied, you just multiply them. And same thing with division, except that notice it says given that g of x cannot equal 0 because the denominator can never equal 0 in a fraction. Okay, so that's some basics. Now, a couple of notes here. The domain of these functions are the x values that work for both functions. In all honesty, harder than doing the adding, subtracting, multiplying, dividing is going to be finding the domain. But please remember, domain are x values, right? Domain is x, and they have to work for both functions. And then when we divide, when we use the quotient function, keep in mind we will need to consider the denominator and any excluded values. Again, because the denominator cannot equal 0. So, domain is x values, and then when we're dividing, don't forget the denominator cannot equal 0. So we will look at our excluded values, which, no, that comes in a later chapter when we look at more excluded values. But anytime you have fractions, you have to consider it. So let's look at example 1. Let f of x equals 4x plus 7. G of x equals square root of x plus x. 3 questions. What are f plus g, f minus g, and their domains? So technically 4 questions, but. Okay. In order to find f plus g of x, what's that mean I'm doing? I'm taking the 2 functions and adding them. I'm going to do f of x plus g of x, which what is f of x? 4x plus 7 plus g of x, which is square root of x plus x. Now, officially, to begin with, I can kind of think of those as in parentheses, and I'll zoom in more so you guys can see them. So officially, that's what we're doing. We're adding f and g. Now, do my parentheses mean anything here? Do they do anything for me? No, they're just kind of separating that it's f plus g. If we drop those parentheses, is there any type of simplifying we can do? Kendra? Yeah, like terms. 4x and x are like terms. So what is 4x plus 1x? 5x. Okay. Are there any other like terms? No. The other 2 pieces are a 7 and a square root of x, which there's not like terms there, so they just carry down into your answer. Now, officially you can write them in either order. I tend to go from highest to lowest power. So I have 5x plus square root of x plus 7. If you put 5x plus 7 plus square root of x, that's fine. MathXL would see it as fine too, as far as I know. But unless you can simplify any farther, guess what? You're done right there. Okay?
Where does the times x come from in f plus g times?
It's not times x. This is f plus g of x. When we talk function notation, look, notice that this is f of x. and this is g of x. That x is not times x, it's just part of the notation.
Oh,
Because it's the function of x.
so you're just adding what f of x equals and what g of x equals
Uh-huh.
together.
Yep. Don't make it any harder than that.
Got it.
You're really overthinking it if you do. Okay, the next thing we're asked to find is f minus g of x. Which if we're asked to find f minus g of x, that means we're finding f of x minus g of x. And f of x here is 4x plus 7 minus g of x, which is square root of x plus x. Now, I put the parentheses around them again. Do my parentheses mean something this time? A little. I mean, generally speaking, it's still just subtracting. But what's important about the fact that it's subtracting? This minus sign does what?
Turns the entire thing negative.
Yeah, it subtracts this whole second thing, whole second amount. So Eli commented that it turns the whole thing negative, which if they're both positive, yes. So it means we're going to be subtracting square root of x, but more importantly, we're also going to be subtracting x. So we're going to be subtracting square root of x and x. But other than that, it's just a matter of cleaning up still. So, what you got for me? What do you see in terms of x's this time?
4x minus x.
Yeah, it's 4x, and we're subtracting anything in the second parenthesis, so 4x minus x makes it 3x. Square root of x and 7 still don't have anything to go with each other, right? So they're going to carry down. What's the catch here, though? Yeah. Even though there's no other square root of x, this square root of x is being subtracted from the first amount. So that means it's going to be minus square root of x. And what about the 7? It's still plus 7 because it's before the minus sign. So we have 3x minus square root of x plus 7. Are we okay with that part of it? Okay. Now, the other thing is it asked us to find their domains. And notice it says the domain of the functions are the x values that work for both functions. Officially, and it doesn't always make a difference, but it sometimes does. So officially, what I'm going to ask you to do is think about the domain for f, think about the domain for g, and then put those together. And look if it affected anything at the end. So, let's talk about the domain for f. Now, remember, domain are my x values, right? So when we look at this, are there any x values that we can't use in just f? So what was f? 4x plus 7. Are there any values you can't put in 4x plus 7? Positives, negatives, fractions, decimals, 0, do they all work? They do, because you can take any number you want and multiply it by 4 and add 7, yes? No restrictions there. So for my domain for f, I'm going to note that it is all reals. Okay? Now we need to consider the domain for g. What was g? Square root of x plus x. Can I put any old value of x that I want in there? No. Why no? Can't take the square root of a negative number? Okay. This is an even root. It's a square root. Can we take the square root of a negative number? No. So any negative numbers are out of the question here. Can we technically we can do positives. Can we do fractions, decimals? Yeah. Yeah. Can we do 0? Yeah, the square root of 0 is 0. Okay. So how do I, you guys said no negatives. So no negatives, then you're telling me it has to be what? Positive. What's a better way to say that than saying positive? I'm not arguing positives, but what's a more mathematical way to say positives? All numbers that are greater than 0. Technically, could it equal 0?
Oh,
Greater than or equal to 0. So I'm going to say that my domain for G is x greater than or equal to 0. Because when you say x greater than 0, that's saying positives. And then my question became, do I include 0? And we are including 0 here. So now, when we added f and g and subtracted f and g, did anything really change with that? No, it's still all reals with the exception of has to be positive for the square roots, doesn't it? So for my final answer domain, because it wanted them for f plus g and f minus g. So my domains for f plus g and f minus g, I'm going to use x greater than or equal to 0. I can no longer say just all reals when we put them together, because we have to consider that there is a radical in those answers. There's a square root, so we have to go positive. Okay? If I recall correctly, Math Excel might do some multiple choice on the domain. I can't remember. Okay, you got an idea there? Let's try B then. F of x equals 2x squared plus 8. G of x equals x minus 3. F plus g, f minus g, and their domains. I almost wonder if I should have skipped this one. Oh well. It's good practice. Okay, so f plus g. What are we doing? We're adding 2x squared plus 8 and x minus 3. So you're adding the first function and the second function. What do you get when you add those together? Put them together. What do you got, Kendra?
2x squared plus x plus 5.
Okay. There's a 2x squared, no other like terms. There's an x, no other like terms, so those carry down. And there's a whole number 8 and a minus 3. 8 minus 3 is 5. And unless there's any other like terms you can put together, you're done there. Let's try f minus g.
Sorry.
I'm listening.
I don't know if I'm just blanking today, or I guarantee we've actually already learned this, but why does x not combine with 2x squared?
Because they're not like terms. In order to add or subtract, they have to be like terms, which means the variable parts have to be identical.
Right.
Same thing with radicals. In order to add and subtract, the radical part has to be identical, everything about it. So the x part has to be identical. You can't add different exponents.
Okay, so it has to be x squared.
X squareds add with x squareds. X's add with x's. They don't intermix. But then to confuse that, you can multiply them. So it's just, at this point in your life, it's just a matter of getting those rules straightened out and permeated in your head so that they don't leave. Okay. F minus g. What changes here? We're subtracting everything in the second function, yes. So let's see. 2x squared is still 2x squared. What about the minus? We're going to subtract x, which makes it minus x. And now we're going to be doing 8 minus negative 3. What's 8 minus negative 3? 8 plus 3, which is 11. So 2x squared minus x plus 11. Okay. Can you start thinking domain? Think about them individually here. This is just a good habit to be in. So, domain of f. 2x squared plus 8. Are there any numbers you can't put into 2x squared plus 8? No. So, f is going to be all reals. Domain of g. Are there any numbers that you can't put into x minus 3? No, you can subtract 3 from anything. So domain of g is all reals. So now, what about f plus g and f minus g? Did anything change with those answers when they got put together? Can you still put any number you want in for f plus g and f minus g? Yeah. So my domain for both of those are going to be all real numbers. Okay, all real numbers there. Okay, we can briefly start looking at C. We'll obviously have to finish C tomorrow. What's different about what we're doing in C? We're going to be multiplying and dividing. They changed the questions they're asking, right? So you have to watch for that in homework. Nothing fancy though. If you're being asked to do FG, that means we're being asked to multiply f of x times g of x. So that means I'm going to have to multiply x squared minus 9 and x plus 3. How are you going to multiply those? Binomial times binomial means, yes, we need to FOIL. You've had a lot of FOILing practice lately, right? X squared times x, x to the third, x squared times 3, 3x squared, minus 9 times x, minus 9x, minus 9 times 3, minus 27. Clean up. It's done. Okay, that is cleaned up because there are no like terms. Tomorrow when we come in, we'll talk about the tricks of dividing because there are some tricks of dividing. Okay? I mean, I guess you could go ahead and write it out, but we won't be done. So we'll divide tomorrow. And then we'll also have to talk domain tomorrow. Okay, because we started by talking about IXL, we don't have nearly as much done as we would have otherwise. You're welcome to look at homework tonight, but I don't know that, you know some of it, so you can figure some of it out. But you can also wait to work on homework tomorrow night. If you did not get IXL done for any reason whatsoever, excuses are out the door now, get the IXL done. And I'm not saying go for a smart score of 100. I'm saying put at least 30 minutes of time in and get a decent score. Okay? Don't leave me hanging at 0 because I can't give you credit if you get a score of 0. Even if you did sit there and work for 30 minutes, supposedly. Because I don't know what kind of effort you put in at that point. Truth. Working for 30 minutes and putting 30 minutes of effort in are two different things.